We have seen equations of lines in two forms, Cartesian form as well as vector form. These forms can be converted from one form to another form. Now see this example. Direction cosines of the line 2x plus 1 is equal to 3 minus 2y is equal to 4z plus 5r. Now this is equation of line in Cartesian form. But here equation, it is not in required form. First we have to convert it into required form. Equation of line in Cartesian form should be x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. It means that coefficients of x, y, z, they should be equal to 1. To make coefficient of x 1 here, we have to take 2 into bracket x plus 1 by, as we have taken 2 common here, second term 1 by. Here make coefficient of y equal to 1. Here instead of 2 we have to take minus 2 common because term of y is negative. Minus 2 into bracket y minus 3 by. If we open this bracket, we get these two terms. So we have not made change in expression, we have made only the adjustment. Here coefficient of z is 4. To make coefficient of z as 1, take 4 common. Now coefficients of x, y, z equal to 1 each. But we don't want any number outside bracket. Now here 2 minus 2, 4 are there. We have to eliminate these numbers from the numerator. For that, divide by 4. If we divide by 4, 2 gets cancelled, 2 remains in denominator. So, x plus 1 by 2 divided by 2 is equal to y minus 3 by 2 divide by 4. So in denominator we get minus 2. Here 4 gets cancelled. Z plus 5 by 4. Nothing is there in denominator, means 1 is there. Now equation of line, it is in required form. From this equation we get coordinates of one point on the line and direction ratios of line. In the options, direction cosines are there. So we did not find coordinates of point. What we have to find is direction cosines. Here numbers in denominator, they are not direction cosines, because sum of squares of direction cosines is equal to 1. So direction cosine may be equal to 1 or less than 1. It cannot be greater than 1. So these are the direction ratios. 2 minus 2, 1. From direction ratios we can find direction cosines. If direction ratios are A, B, C, direction cosines are L, M, N, then L equal to A upon under root A square plus B square plus C square. Sum of squares of direction ratios, and that in under radical sign. So under root 2 square plus minus 2 square plus 1 square. Under root 4 plus 4 plus 1. Root 9. As 9 is perfect square, its square root is 3. Actually, here we need not find value of under root a square plus b square plus c square, because in each option denominator is 3 only, means its value is 3. Then direction cosines. Divide by under root a square plus b square plus c square to the direction ratios, we get direction cosines. So we get 2 by 3 minus 2 by 3, 1 by 3. Now compare it with the options. Here answer is option C. Next example. We have to find vector equation of line. Where equation of line, it is in Cartesian form. 2x minus 1 is equal to 3y plus 2 is equal to z minus 2. Now this equation, although it is in Cartesian form, it is not in required form. We want coefficients of x, y and z as 1. Here coefficient of z is already 1. We have to make coefficients of x and y also equal to 1. So here take 2 common. In bracket x minus 1 by 2 is equal to, here take 3 common. 3 into bracket y plus 2 by is equal to z minus 2. Now we don't want numbers outside bracket. We have to cancel 2 and 3 from the numerator. LCM of 2 and 3 is 2 into 3, 6. If we divide equation by 6, then 2 and 3 from numerator get cancelled. Divide each side by 6. If 2 gets cancelled. X minus 1 by 2. What remains in denominator? 3 is equal to y plus 2 by 3. 3 gets cancelled. 2 equal to z minus 2 upon 6. Now equation in Cartesian form we have converted into required form, so that we get coordinates of one point on the line and direction ratios of line. From numerator we get coordinates of one point on the line. Numbers in denominator, they are direction ratios of line. And here we want equation of same line in vector form. Cartesian form can be converted into vector form. Vector form can also be converted into Cartesian form. For getting equation of line in vector form, what we require is position vector of one point on the line and vector parallel to the line. Now here, from numerator, we get coordinates of one point on the line. x1, 1 by 2, y1, negative, minus 2 by 3, z1, 2. Numbers in denominator, they are direction ratios. A3, B2, C6. These are the coordinates of one point on the line. And when we know coordinates of one point, then we can find its position vector. In the position vector, coordinates of point, they become coefficients of unit vectors ij. Suppose it is point A with position vector A bar. 1 by 2 I minus 2 by 3 J plus 2 K. Now we have got direction ratios of a line. For parallel lines, direction ratios are same or proportional. Now we want vector parallel to line. If direction ratios of line are known to us, we can write vector parallel to line. Those direction ratios, they become coefficients of unit vectors ij. So p bar equal to 3i plus 2j plus 6. This is position vector of one point on the line. This is vector parallel to the line. Then equation of line in vector form, r bar equal to a bar plus lambda b bar. Put the corresponding values in one bracket. 1 by 2 I minus 2 by 3 j plus 2 plus lambda into bracket 3i plus 2j plus 6. Compare it with the options. We can observe that answer is option A. Now in this particular example, here even if we don't find vector parallel to line b bar, then also we can get correct option, because this is position vector of one point on the line and it is present in only one option. Other options do not contain terms of k, means their coefficient of k is 0. Next example, cosine of angle between the lines, p bar equal to I plus j plus lambda into bracket I plus 2j plus 2 and p bar equal to I minus 2j plus mu into bracket I plus 2j. Now equations of lines, they are given in vector form. In first bracket, position vector of one point on the line. In second bracket, it is a vector parallel to first line. For this line also, this is position vector of one point on second line. This is vector parallel to second line. Here coefficients lambda and mu, different coefficients are used because those constants may differ from line to line. So here equations of lines, they are in vector form and we have to find cosine of angle between them. If theta is angle, we have to find value of cos theta. But these equations, they are in vector form. In that form also we can find angle between lines, but it is more convenient if we find direction ratios of line. It will be more convenient. Now this is a line parallel to this vector. Coefficients of ijk, they are direction ratios for first line. 1, 2, 2. For second line, this is vector parallel to it. Direction ratios, coefficients of ij. One, 2, 0. Now we can find cosine of angle between them. Cos theta, a1 a2 plus b1 b2 plus c1 c2. 1 plus 4 plus 0 divided by under root a1 square plus b1 square plus c1 square. 1 plus 4 plus 4 under root a2 square plus b2 square plus c2 square. 1 square plus 2 square plus 0 square. 5 by 9 perfect square 3 root 5. 5 can be written root 5 into root 5. One factor gets cancelled. So root 5 by 3. So here answer is option B. Equations of y-axis. In two-dimensional geometry, equation of y-axis is x equal to 0. This is three-dimensional geometry. Equations of y-axis, x equal to 0, z equal to 0. Answer is option C.